Okay, let's take a look at some of our network analysis techniques and theorems. Okay? To start with, we can look at this using Thevenin's theorem. Right? We could look at this using Thevenin's theorem, and we could say find the current through R3, right? Or, better yet, find the current at that point. Any ideas? How do we find the current at that point? That's correct. I kind of already let the cat out of the bag. But yeah, anything that's going to be current through these two resistors, either one of them, will also be the current at that point. Yes? So kind of think out of the box a little bit. So I could use Thevenin's to find the current through R3, could I not? All right, so let's go ahead and do that. What's the first thing we do with Thevenin's? Pull out the load. Okay? So we do that, we labeled A and B, right? Now what? Now we got to go around the loop, right? Find the voltage drops. So I can simplify this. Is R5 going to get any current? No. So if I were to do a circuit redraw, I could just have these two branches, right? Okay. So if I had just those two branches, can I treat this as one resistance? Which would be 3K, right? I'll call that REQ1. So that's basically what I'm dealing with there, right? With one exception. I've got to put in my A and B. For all intents and purposes, that would be A and B, would it not? Sure, there'd be an R5 in there, but R5 doesn't get any current, so it's not going to factor into voltage Thevenin. Okay. Do I even need to find a voltage drop for that REQ1? No. If I just find the voltage drop for R4, that's more than enough. That gets me from A to B. Nevertheless, what is my total voltage applied here? My EA, 30 volts. Okay. EA is 30 volts. What's my total resistance? What's the resistance around the loop? 7K. So that gives me a total current of what?
They're not in parallel.
They're not in parallel, it's a loop.
4.28.
What is it?
4.28
4.28 milliamps. Which direction is current going? Clockwise, so I can write in my polarities for R4, that's the only one I need. Negative, positive, is that correct? Yes. This current's going this way. All right, with 4.2 milliamps, 4.28 milliamps as the current, 4 k ohms as the resistor, what's the voltage drop on R4? 17.14 volts. Can I now go A to B? Okay, so I come over A, I hit the node, I go down, I hit negative 17.14 volts, positive 15 volts. Where am I at right now?
2.14.
Negative 2.14 and back to B. So my voltage Thevenin
1.14 volts.
is 2.14 volts, and the orientation will be negative, yes?
Yes.
All right. Next thing I want to do, what? Resistance Thevenin, right? Okay, so let's start at A. I come out of A, what do I go to? A node, yes? Okay, I go down on the node. I hit R4. I go continue left on the node. I hit that REQ, which was 3K. I continue down from there. I hit ES1, which I'm going to short. I go around. I continue down on R4. I hit ES2, which I'm going to short. The bottom of ES2 marries up with the bottom of ES1. And then I hit R5. Now does R5 matter? And then I hit B. Okay. Total resistance now, right? Over here it's going to be 3K times 4K over 3K plus 4K for a product over sum, which would be 12K squared over 7K, which equals what? 1.71K, and I add that to 5K, giving me 6.71K for my RTH. Okay, time to draw the third redraw, yes? Which way is my source going to be oriented?
Negative.
Negative terminal up. Thevenin resistance. My load resistor, which was 3K. Source voltage, 2.14 volts. All right, what's my total resistance here? What's that? 9.71K. Okay, and then I can now find my total current, right? IT will be 2.14 volts divided by 9.71K. 220 microamps. Okay, so going up this leg, I've got 220 microamps. As you were, yes, I was going that way. Let's see what else this was good for.